Hello guys, welcome back to our channel. Today we are going to see the what is a even parity checker and how it will be performed. In the previous video we discussed about even parity generator. The even parity generator is used to generate the even parity for the input bits, and this even parity checker will checks the whether the generated parity is correct or not. That means assume that the even parity generator is a transmitter, yet this even parity chakra is a receiver. It takes the inputs and the parity and verifies whether it has a error or not. That the main difference between the even parity generator and the even parity checker, here we require 4 XOR gates, and extra XOR in the even parity generator we require 3, here we require 4. An extra XOR gate is required to check the parity bit. Okay, in the previous day we created a 4-bit even parity generator, right? So today we will design a 4-bit even parity checker to verify the parity whether it is error or error free. Okay, so for that we require a 4 XOR gates. One XOR gate, this one is the second XOR gate, and third XOR gate, and finally fourth XOR gate. Okay, here what are the inputs? A, B, C, D. Here we will get the A XOR B, and here we get the C XOR D. Both the inputs are given to the this XOR gate. Here we will get the A XOR B XOR C XOR D, and this will given to the one of the input of the XOR gate, and another input will be the parity, right? This parity will be given to this, and finally we get the P XOR A XOR B XOR C XOR D. Okay, if we get the output is equal to 0, that means if the parity and this XOR operation is if are the equal, then the output of the XOR gate will be 0, and this indicates no error. If output is 1, then we have error. Okay, now let us verify. Suppose here you can see that if we have 0011, let us take this example. What we have to get the parity is 0. So let's verify whether it is correct or not. I am taking the inputs as 0011, and here parity as 0. Okay, now if 00 are applied to the XOR gate, then now what is the output here? So if the same inputs are there, so our output also 0. Here same inputs are the output is also 0. Both the same inputs are applied to the XOR gate, same the output will be 0. Here also same inputs are giving, so output is 0. So 0 means there is no error. Suppose if the parity bit is 1 here, then 1 0 the output will be 1 and it has a error. So in this way this even parity checker will checks whether the received parity or the received information is correct or not. Okay, now let's make the verilog code to make the even parity checker. Okay guys, now let's make starting the verilog code for the even parity checker. So for that I am creating a module with even checker name, and I'm taking the input. We require a 4 inputs, right? 5 inputs: A, B, C, D, comma P. P is nothing but the parity, and output is Y. This output will be maybe 1 or 0. Based on the output, we will decide whether there is an error or not. So I'm assigning Y is equal to A XOR B XOR C XOR D XOR P. Okay. So this is the design code for our even parity checker. Now let's make the test bench code. So what is the test bench? Module TB register A comma B comma C comma D comma E, and where only one output is there. So okay, even checker, we extract the inputs and the output from the module. So A comma B comma C comma D comma E comma y. Okay. Now I am going to start giving the initial begin monitor command which is used to display the information in the display console. Okay. Mm, equal to percentage b, b equal to percentage b, c equal to percentage b, b equal to percentage b, b equal to percentage b. Here a comma b comma c comma d comma p comma and y also is also there, right? So y equal to percentage b. Now I am start giving the input a equal to, we discussed this example as double zero double one, right? So a equal to 0, b equal to 0, c equal to 1, b equal to 1. I am giving the time delay as just 5 seconds, and I am also giving the parity. One, the actual character parity is 0. Now we will give 0 as well as 1. Let's then we will verify whether it is detecting the error or not. So for the first second sequence, the output must be 1. Then our code is correct. So end module. Now I'm selecting the tools and the simulators. I'm going to run save this file and I'm going to run this. Here I am giving the name as like event checker, and I'm again saving this file and I will run this. There is something error called test .12 here. Yes, here we have to give some command called $finish which will end the test bench. Now I am going to run this file again. Yes, here you can see that for the first sequence we received as a y as a 0, that means there is a no error. And for the second we received a y is equal 1, that means we have a parity is equal 1. This is an error. So in this way, this code is perfectly working. So thank you for watching this video. You can find it this code in our description. If you have any doubts, please mention in the comment section. Thank you for watching and stay tuned for the next video.